Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how your brain figures out what a brand new word means, especially when it is a made-up one? Today we're diving into some fascinating research that explores just that. Imagine you hear a word you've never heard before, like tiger collar. You know what a tiger is and you know what a collar is. How does your brain instantly put those together to guess what a tiger collar might be or what it might look like? Scientists are super curious about this and call it zero-shot learning. It is like giving your brain a mystery to solve with just a few clues. The big idea here is called conceptual systems alignment. Think of it like this. When we use words in similar ways in language, those words often describe things that also have similar features in the real world. For example, words like tiger and leopard are used in similar contexts in sentences. And guess what? Tigers and leopards look pretty similar too. They both have fur, whiskers, and are big cats. The researchers in this study wanted to see if our brains use this connection between language clues and real-world features to understand totally new concepts. Now, testing this in humans is tricky. True novelty is hard to create. If a concept is completely new, it doesn't even have a name, so we can't even talk about it to test people's understanding. So these scientists got really creative. They decided to use compound words. Like tiger collar. These words are made up of familiar parts, but the combination itself might be new. This way, the words have a kind of on-the-fly interpretability, meaning we can understand them by combining the meanings of their parts. To test their ideas, they created a bunch of new compound words. For each word, they imagined different ways it could be interpreted. For tiger collar, one interpretation could be a collar that looks like a tiger's stripes, maybe furry. Another could be a collar designed specifically for a tiger. They then used powerful AI like DALL-E 3 to create lots of different pictures for each of these interpretations. They made typical pictures for each idea, meaning ones that looked most like what you'd expect, and the typical ones, which were a bit stranger. They also created a control image showing just the main part of the compound word, like just a collar. They then had people try to imagine what these new words would look like and pick the picture that best matched their imagination. They also timed how quickly people made their choices, using fancy computer models that understand how words relate to each other and how images relate to each other. They tried to predict which pictures people would pick and how fast they'd pick them. Before they tested people, they first looked at how well their computer models could do. They trained models on tons of text to learn word relationships and on huge image datasets to learn visual relationships. They found that their models were pretty good at linking the language world to the vision world. They could even predict how typical an image of a familiar concept was, based on how language described it. This means that what we say about things is connected to how they actually look, even down to the details of what makes a good example of something. Then came the human part. The core of the study, they presented participants with those novel compound words and two images, asking them to pick the image that best matched their mental picture of the word. They found something really interesting. Their language models, which combined the meanings of the word parts, were pretty good at predicting which interpretation people would choose. For example, if the language clue suggested that tiger collar was more about stripes, people were more likely to pick an image with stripes. They could also predict how fast people made their faster choices when the image strongly matched the language prediction. However, here is where it gets a bit more nuanced. While language clues helped predict which type of image people would prefer and how quickly they'd choose it, they weren't as good at predicting which specific image within that interpretation was considered the best, or most typical. Remember how they made typical images for each interpretation. The language models struggled to correctly predict which of those two would be picked more often. This suggests that while language is great for guiding us towards the right general idea, the finer visual details of what makes a perfect example might involve more than just language patterns. Think about it like this. If you hear fire truck, you know it is a kind of truck and related to fire. Your language knowledge helps you pick a picture of a truck that looks like a fire truck, rather than, say, a regular delivery truck. The speed at which you do this also reflects how clear that mental image is. But if you are shown two slightly different pictures of fire trucks, one with a very classic ladder and another with a slightly unusual water nozzle, language alone might not tell you which one is the absolute best or most typical fire truck. Visual experience and subtle perceptual judgments might play a bigger role there. So, what does this all mean? It strongly supports the idea that our brains use the connections between how words are used and how things look to understand new concepts. This conceptual systems alignment is a powerful tool for learning. When we encounter a new word, we can leverage what we already know about language to make educated guesses about what things look like. But it is not perfect. This research suggests that while language can guide us to the right category or interpretation of a new concept, it might not be enough to perfectly nail down the visual details of what the best example looks like. That level of fine-grained visual judgment might rely more on direct visual experience or more complex internal visual simulations. This has big implications for how we think about minds and machines. It shows that when we combine concepts, like in those compound words, it is not just a simple addition of meanings. There is a sophisticated interplay between language and vision. The fact that the computer models, which are getting incredibly good at understanding language and images, can partly predict human behavior in this very complex task is a huge step forward. It pushes us closer to understanding how humans can learn and adapt so quickly to new information. Of course, no study is perfect. They acknowledge that they had to simplify things a bit. For instance, they focused on just 2 main ways a compound word could be interpreted, destructive or non-destructive. In reality, things can be much more nuanced. Also, the AI-generated images, while very good, are still artificial. Future research could explore how real-world experience, not just abstract language patterns, shapes our understanding of novel concepts. Perhaps looking at even more complex combinations or introducing different sensory experiences could reveal even more about this amazing ability of our brains. Ultimately, this study gives us a peek into the clever ways our brains make sense of the world, using language as a powerful guide to connect with unseen visual realities. It's a testament to the rich, interconnected nature of our cognitive systems. What do you think? Have you ever experienced something like this? Encountering a new word and having a strong guess about what it means or looks like? Let us know in the comments below, and if you enjoyed this deep dive into the science of the mind, be sure to like this video and subscribe to RUBIN'S Mind Lab for more fascinating research breakdowns. We'll see you next time.